A very good morning, friends. Today we are going to discuss about collision theory. Collision theory. We are going to discuss about collision theory here. So what is the collision theory? So collision means what? Two reactant molecules should be collide with each other. Okay, two reactant molecules should be collide with each other. So here what happens? For collision also we have some rules and regulation. It means some characteristics are there. So when collision takes place, two or more than reactant molecules should be there. Reactant molecules should be there. Reactant molecule should be odd and sphere. Reactant molecule is odd and sphere. Here what happens? But here what happens? One condition is there. All reactant molecules does not form product. It means it is one reactant molecule is there, one reactant molecule is there. It is coming towards this like this. Then they will come under collision. But when there are two reacting molecules are there, so if it goes this way, if it goes this way, so what happens? They will not collide with each other. It means all reacting molecules need not to form product formation. Okay, when they collide with each other, then only they form new product. You are getting my point. So all reactant molecules should not be form product. So to form product, what is the main capacity, what is the main condition we have to have? So what happens? Molecules with certain kinetic energy. Here listen, certain kinetic energy, proper orientation. Okay, let's do product formation. Suppose I will tell you here product formation. Here I will tell you, suppose here one reactant molecules is there, here one reactant molecule is there. From up to here we should have kinetic energy 1. Here also we have to use kinetic energy. If they have certain amount of kinetic energy, they will reach here. Then only they will undergo collision. So final they will form product formation. You are getting my point. It means orientation is also correct. It is in straight line. It is in straight line. It is in straight line linear motion. They will undergo collision. So if orientation leads to in this direction, so if orientation is not proper, they will not form product. You are getting my point. So that's why there and must should be certain kinetic energy and proper orientation should be there to form product formation. Okay, this is the main concepts of collision theory. So here happens, we listen in up to in 10th class also, endothermic reaction and exothermic reaction. Endothermic reaction, exothermic reaction. So endothermic reaction means what? Here what? This is reactant molecules. They will undergo like this. Here intermediate reaction will be there, intermediate reactants. So finally they will form product. So what happens? This distance is here. This is up from here to here total energy. This is activation energy for forward reaction. F means forward reaction. Forward reaction up to here. This is the highest point. From here also we have to consider. This is activation energy for forward reaction. From here to product formation, this is called backward reaction. Okay, activation energy of backward reaction. So EAF is more than EAB, then only it will comes under endothermic reaction. Here what ampere? EAF is greater than EAB, then only it will comes under endothermic reaction. Here what happens? Delta H should be there. Delta H will be positive. We have to add delta H. So both of delta H and delta EAB comes under EAF. You are getting my point. Comes under exothermic reaction. Come to exothermic reaction. So this is reactant, this is product. Here product formation is more than reactant molecules. Here what happens? Up to here this side, EF is there, EAB is more. It means EAB is greater than EAF. So finally EAB is equal to delta H plus EAF. If you want to find out EAF, what happens? EAB minus delta H. Then only in exothermic reaction delta H will be negative. In endothermic reaction delta H will be positive. We always sometimes we will always read that about endothermic reaction delta H is positive like that. So that means this is the main reason. You are getting my point. So next we are going to we go for collision frequency. Okay friends, next we go for collision frequency. Collision frequency. Here collision frequency, here what happens? Collision frequencies, number of collisions per unit time per unit volume is called collision frequency. Okay, this is the main point. Number of collisions per unit time within one volume. Okay, number of collision per one unit or per unit volume, that condition is called collision frequency. So you take this reaction, A plus B gives rise to one product formation. A plus B gives rise to product formation. Here what happens, rate is equal to Z AB, you are getting my point, Z AB EA power minus ERT. This equation you know, Z A EA power minus, this is Arrhenius equation. So Z per AB, this is called collision frequency. Z is called collision frequency. So after that, one constant we will use, that is called P. P is steric factor, probability factor. Okay, probability factor or steric factor, whatever you take. Okay, this is P Z A B EA power minus RT. These are the very main important formulas you have to remember. You are getting my point. Z is collision frequency, P is steric factor, probability factor. Okay, so up to here chemical kinetics is over. So up to here chemical kinetics is over for MSET, NEET and IIT JEE mains. Collision frequency, up to collision frequency, this chapter is over. So dear friends, what I am asking you means, so if any fault in my teaching, okay, please comment on the box. I will rectify. It means I will totally I will change the defects whatever present in my teaching level. Okay, thank you. So all the best. Thank you friends. Bye. Thank you.